Welcome to Autism Mathematics. This is where we give you the right foundation in the study of mathematics. I am on a series, the 7 building blocks of mathematics. The third block, which is change of subject. And under change of subject, I'm looking at the third case, relation involving exponent and root. Now before I continue, if you have not subscribed, just click on the subscribe button, and then you can also turn on your notification so that anytime I drop a video, you'll be alerted. So as I said, relations involving exponent and root. So let's look at some basic this concept. If x squared is equal to b, if you want to find x, anytime you have a variable square and you want to find that variable, then what you can do is to take square root on both sides. So when you take square root on both sides, x will become plus or minus, take note, square root of b. Now if you have a variable under square root sign and you want to find that variable, you square both sides. So the square will take care of the square root sign. So x becomes, and then let's move on to the third cube. If x cube is equal to b and you want to find the variable, then you have to raise both sides to the power 1/3, which means taking the cube root on both sides, taking the cube both sides. So this 3 will cancel, so x becomes the cube root or raised to the power 1/3. So assuming that you have the end root of x, so you raise both sides to the power 1/n. Take n so that you have x is equal to b raised to the power n, and so on and so forth. Let's come back to the question. We are to make g the subject of the relation. T is equal to 2 pi times square root of L on g. Now let's look at the variable that we want to make the subject. It's under the square root sign. So as we have explained here, if the variable is under the square root, to get rid of the square root, you square both sides. But before we do that, let's move this one to this side. It's multiplying, so if you want to move, then you divide. So we have t over 2 pi equal to square root of L. Now we want to get rid of the square root, so we square both sides, so that we have t squared over. Now the square will affect the number 2, so 2 squared will be 4 pi squared. This is equal to, and the square will take care of the square root, so the square root will disappear. L on, we want to find g, so we can cross multiply. G will multiply t squared and the L will multiply 4 pi squared. So we are going to have t squared is equal to 4 pi squared L. Always keep in mind the variable that we want to make the subject. I want to make g, so we can divide both sides by t squared. 4 pi squared L. Square will cancel t squared, so g can stand alone. 4 pi squared L on t squared. That is our answer. Let's look at the next example. We are to make y the subject of this relation, and y is under the square root sign. So before we come to the square root, there is a variable here. We need to move it to the left hand side. So this implies that 2x minus p. I've explained that the sign here is positive, so as soon as it crosses the equal sign, it becomes, the sign changes, minus. This is equal to square root of y squared plus z. Now y is under the square root sign, so we can square both sides. Now remember, it's not about squaring term by term. You put them together and square. So we have 2x minus p all squared is equal to, so this square will take care of the square root, so it will disappear. We have y squared plus z. Now we want to make y the subject. We can rewrite it as, bring y square plus z is equal to 2x minus p all square. We want to make y to stand alone, but this guy is worrying him. Z, we need to take z to the other side. So we have y squared is equal to, is plus here, so when it crosses this equal sign, becomes negative x minus p all squared minus z. Now y is raised to the power 2. Now to get rid of this guy here 2, we need to take the square root, as I've explained. And once again, the whole expression on the right hand side is not about taking the square root term by term. You put the whole expression under the equal sign. So we take square roots on both sides. Take the square root on both sides. So square root of y squared becomes square root of the whole expression 2x minus p all squared minus z. Remember, the square root covers the y is equal to, I've told you, when it is 2, then we are going to have two solutions, plus or minus square root of this whole expression x minus p all squared minus z. So that is our answer. So far I've solved 2 questions, so I want you to pause the video and try this one as I go through with you. So after, you check with your answer if your answer is correct. So let's, given that p is equal to x plus ym cube, express m in terms of p, x and y. So this is the variable that we want to make the subject. So once again, we can rewrite this one as x plus y is equal to, this implies that m, the subject, we need to move this one to this side first. So we have ym cube equal to p minus, this implies that still there's another guy y, this y here is worrying m, so we need to take it off both y, divide both sides by y. So y will cancel y, and we are going to have m cube equal to p minus x on y. We have to make m the subject, not m cube. And as I explained it in the first question, if the variable is raised to the power 3, then we need to take the cube root, that's raising both sides to the power 1/3. So we can raise both sides to the power 1/3. So this to the power 1/3. Whatever you do on the left hand side, you do the same thing on the right hand side. So these 3 will cancel, making m is equal to bracket bracket open, p minus x on y, all raised to the power 1/3. But as I've been doing, there are times that if this is supposed to be an objective question, you may not see this. You can still rewrite it as m is equal to, you can write it the cube root of p minus x on y this way. You can rewrite it as this way. So if this happens to be an objective test, if the first one is not in the options, you can try the second one. Let's look at the next one. We are to make k the subject of the relation, this k. So as I've been telling you, you first look for where k is. Once again, k is under the square root sign, so we need to get rid of the square root. You need to get rid of the square root, and I've explained that to get rid of the square root, you square both sides. So we have 1 on n is equal to square root of k squared plus p squared on hg. So let's square both sides to get rid of the square root. This implies that now 1 squared is the same as 1, n will be n squared, which is equal to, we have k squared plus p squared over, so you ask yourself, what am I supposed to make the subject? Is k, is here. So let's cross multiply. So you have n squared times k squared plus p squared is equal to hg times 1 is still hg. We can expand because we have it. So n squared k squared plus n squared p squared is equal to h. Well, we want to find k. So n squared k squared, let's move these ones to this side, is equal to, so hg will come first, hg minus n squared. Now we want to find k, so let's first divide both sides by n squared. So this n here will cancel n, so we have k squared is equal to hg minus n squared p squared over n squared. We are to make k the subject, not k squared. So once again, if it is square, you take the square root on both sides. Take the square root on both sides. Take the square root on both sides. So k is equal to, then plus or minus square root of hg minus n squared over. Viewers, this is the end of today's lesson. Once again, if you have not subscribed, just click on the subscribe button. Thank you very much for doing that. Next time, I'll be combining substitution and change of subject. There are times that you may be asked to make a variable the subject, and then you'll be given values to substitute and find the numerical value of the relation. See you once again. God bless you.